Okay, then yeah, it's about the design of testable ABAP classes and packages. And can't I move on here? Okay, yeah, this way it should work. So a few words about myself. I'm working for SAP for more than 25 years as a developer and architect on the one hand, and on the other hand, as an agile software engineering coach. I have been conducting many workshops and was also developing trainings and also conducting those trainings about agile software engineering practices. And out of all this experience, I wrote this book, Test-Driven Development with ABAP Objects. It's not about greenfield development only. Actually, it's more about the brownfield world. So where you need to get a hold on the application with first tests, yeah, and then start the refactoring and improving further and further. If you do refactor, it's of course the question, how should the new classes and packages look like? This is the topic of today. And other books I have written are about test data classes. So this is an object-oriented pattern for readable and reusable test data, which is quite important in the test world, because you should understand the test case easily, yeah, and you should avoid duplication also in the test world. And test data classes can do exactly this for you. Last but not least, I wrote a book about parallel processing with ABAP objects. So the class we just saw in Thomas' presentation, CL ABAP parallel, is yeah, in the focus of this book, but not only. It was also important for me to have a complicated example, yeah, where I could show how package should be designed in order to mitigate this complexity. Yeah, so it's a lot about designing packages correctly, and this with an application using parallel processing. Okay, so let's look at this topic today, and we start rather simple. So whenever we need a new class, that class should have at least one interface for its public methods. And there should be a factory providing objects of this new class. So the mechanism is then as follows. The factory class, yeah, offers a method to return a new object, so an object of the new class. Yeah, so this is this method. There should be on the new class side, yeah, so-called creation method. Yeah, this is not the same as the constructor. The constructor is just a technical construction of an object of a class, but it does not ensure that this object is valid. Yeah, in the sense of the application. Whereas creation methods, so explicit static methods, starting with the term create normally, yeah, they return valid objects. And this is what other classes who want to work with the new class are interested in. Yeah, so there should be at least one creation method. And since the factory is defined as a friend of the new class, this creation method can be private. So you see it with a minus sign. Yeah. Whereas, of course, the method of the factory, which the world around the new class should use, yeah, is public. You see it with the plus sign here. And yeah, when the create new method returns an object, it does so by reference to the interface. And we will see in the on the next two slides why this mechanism is so useful. So let's have a look, first of all, at the new class definition and implementation. That's all, yeah, at least when it comes to the skeleton of the new class. Yeah, so we haven't thought about the functionality yet. Yeah, it's just about that the technical necessities for testability, yeah, are given. Yeah, and you now can see this is our new class. Yeah, I told you it implements at least one interface. So the interface we just saw, I called it IF new. The class has the factory class as a friend, yeah, so that that one can also call methods in the private section, yeah, which no one else can do. And yeah, here in this creation method of the class, yeah, the constructor is called. Yeah, and maybe further things are done so that the validity of the returned object is guaranteed. Yeah, in this case, I kept it really simple. Yeah, so this is what is true for every new class. That's why I called it the skeleton. Okay, maybe you wonder why the creation method does not return the interface. This is possible, yeah, because this creation method will not be used by the outside world directly, but only by the factory. And the factory knows the class, of course, yeah. So it doesn't bother that the class name is returned. The advantage is that within the creation method down here, if I need to define one or two attributes to ensure validity, yeah, then I can immediately do it. Yeah, if I return here the interface, yeah, then I cannot have that line here. This would now refer to the interface, and the interface doesn't know the attributes. Okay, so I need extra variables and so on. And Thomas just said, yeah, try to avoid extra stuff. So it is better to use here the class type. It doesn't make any difference for the outside world because we have the factory in between anyway. And when we look at the factory code later on, you will see that the create new method of the factory returns the interface. So all is good in the outside world. Okay, so we have now first developments going on. Yeah, our new class was, of course, developed on purpose. Yeah, because this product class here, yeah, with its product method, yeah, needs a method of the new class, and I just called it the new method. Okay, so of course, this offering, yeah, becomes part of the interface. So now I enter this previously empty interface, yeah, and define the new method there, and then of course start implementing it in the new class. And now the procedure is as follows, yeah, and this is the same for all classes using new objects, not just for this product class, yeah. In order to get a new object, yeah, a request, so this is the R request, yeah, to the create new method of the factory, yeah, that one itself doesn't create new objects, yeah, it calls the private creation method of the class doing it. So that one already returns the valid object, yeah, and that one comes back, and here exactly it comes back as the interface, and this is what you see there. After the creation, yeah, the new method is found in the returned interface and can be used. This leads to the following huge advantage. Yeah, there is no connection between this product class and the new class. Yeah, so the product class is only depending on the factory, yeah, and the interface. Meaning, if tomorrow, yeah, I have an idea for a more performing new class, yeah, I could just have another class next to it, let it also implement the new interface. So in this sense, fulfilling the contract, yeah. And then I can simply change this create new method in the factory. So from now on, yeah, not this former new class is to be used, yeah, but the really new one, the latest new one, yeah, and the product class, the product method, and the outside world won't even realize because the contract is still fulfilled. Yeah, what is returned here, yeah, is interface, and it is implemented according to the contract. Okay, so this is also called a full decoupling of these two classes, and this is the foundation for testability. Yeah, because if this is done in the product world, yeah, and we are just talking about this right now, then this can also be done in the test world. During tests, I can just not return an object of this class, but one of a test double. Okay, using the same mechanism. And this is also why I spend so much time now on this, because later on, when I refer to the test double also implementing this interface, then you will understand, yeah, that the mechanism was already provided by the testable design I'm presenting you today. Okay, so now we have a closer look at this product class, yeah, and the interaction I was just talking about. But it's always nice to see it in a diagram, yeah, and then also in the code. And yeah, so you see here the definition of the product class. And in this case, I kept it simple. Of course, there should also be an interface, yeah, for this one, yeah, but then it wouldn't fit on here. So yeah, and now let's look at what we are really interested in right now. Yeah, it is how this product method, yeah, gets first of all a new object, yeah, and then calls the new method on it. Yeah, this is done, yeah, by asking the factory, please give me your singleton object. Yeah, so there is exactly one object of this factory, which then in an instance method, yeah, returns a new object. And the new object, yeah, can then be used to call one of the methods of the new interface. Yeah, and this is done there. Of course, it could also be that the product class, yeah, has this statement already in the constructor, yeah, filling an MO new object attribute, yeah, so that that one is later on available to all methods, not just product method, but also to further methods of this product class. Yeah, so these are just little deviations which don't make any difference. Okay, yeah. The reason why I'm working with a so-called singleton factory, yeah, having exactly one factory object, yeah, instead of a static factory, having no objects, yeah, with just static methods, is simply because then I can redefine factory methods. Yeah, and this is what we will take advantage of. And that's why the singleton factory approach is more flexible. Okay, yeah, before we now dive even deeper in this testable design, I want to introduce you to the color code I'm using everywhere. And so we start with the color we have already seen. Yeah, so that's the one for the productive code. Yeah, and of course our class under test here, abbreviation CUT, class under test, has that productive color. Yeah. What other colors do we have? Of course, when we start testing, then we are working with test classes. Yeah. If we do unit testing, we do it in the local test include of the class under test. Yeah. So there we have then local test classes. Yeah. And those in diagrams show up as blue boxes. Then if we want isolated testing, so we want to test only the class under test, but not all the other classes it depends on, yeah, then we need test doubles. And the color for test doubles is green. Yeah, and here we also use the abbreviation DOC for dependent on class. And the double class, you can see it here. Yeah, so this is a global test double of the class DOC in this case. Last but not least, yeah, it is good in order to avoid duplication and increase the readability, yeah, to have a test infrastructure of help classes. And since these classes are normally reused, yeah, by multiple productive classes and their tests, yeah, they are global. So TH is a global test help class, and the test data classes I just mentioned in my introduction, yeah, are examples of these help classes.
Yeah, Winfried, sorry to interject. I think you're using the mouse pointer on the other screen, so it's a bit hard to. We're not seeing your mouse. Yeah, yeah. Yeah,
okay.
much better, much better. It was. Oh, it's gone now.
Yeah, but then I have to look at the other screen because otherwise I'm not controlling it well enough. So yeah, I cannot look into the camera as before. Hope this is still okay.
Yeah, I think it's fine. Thank you.
Yep, thank you for the hint. Yeah, and now we look at class diagrams. Yeah, so we already learned every class, our class under test, yeah, and the class it depends on, yeah, should have interfaces. So this is what you see here, yeah, and also the factory in between, yeah, should have an interface where all, yeah, the objects it can create are present. And yeah, and as we have seen, yeah, with the product class and the new class, yeah, is that the creation goes via the factory. So I hope you understand this setup here. Yeah. Yeah. Now we want to do testing. Yeah. So this is all productive code. This is the testable design, yeah, so that we can now have isolated tests. What do we need for isolation? Yeah, we want to test this class on its own, yeah, so without the class it depends on. So we are introducing a test double for this class, implementing the same interface, so fulfilling the same contract, yeah, on what this class depends on, and then we also have a test double for the factory inheriting from this factory class. Yeah, so now we can redefine certain methods. Yeah, so like the create of this doc method here. So the question is now, how do we change the setup in the test phase? Yeah, that the double of the factory is used and not the productive factory. Yeah, and this can be done by a help class, so-called injector class. It has just one purpose. Yeah, it is to inject a double of the factory here. Yeah, this is a singleton. So there's always an SO factory attribute, yeah, as we will see soon. And any object which is placed there will be used immediately, yeah, and no new will be created. So let's see how this evolves by having a look at the code of this factory class. Okay, so singleton factory, you can see it on the one hand by, oh, this should actually be static. Yeah, this is also what the S refers to. Oh, sorry. So we should have here a static, so class data as a factory. And we have the get method, yeah, which returns this singleton object. And if it doesn't exist, it is created. Yeah. If the injector as a friend, yeah, has put the double object here before the get is called, yeah, the get will be fine with the double factory and return it. Yeah, and the outside world is of course content with it because it just needs the interface of the factory. Yeah, and this one is provided by both the productive factory and our test double of the factory. Yeah, so this way we change the whole creation process. Yeah, from creating productive objects to creating double objects. Yeah, and this can now be seen here. So we have now such a local test class for our method under test. Yeah, so there is not just one test class for the class under test, yeah, but for each public method, yeah, there should be a separate test class. Yeah, so now we have this local test class for this one method under test. And that one, as we will see then later on also by code, yeah, does the following. Yeah, it creates an object of the factory double class. Okay, then it uses this helper to inject it to the static attribute here. And then it can create an object of the dependent on class. So the class on which cut really depends on, yeah, and inject it into this factory here. And then what happens if during the test run, yeah, the class under test executes its get factory method, or just the get method, yeah, then this one is returned, yeah, and later on I say create a doc, and then this injected double is returned. Yeah, so this way we take out the productive part here completely, yeah, and we only have this part of the productive world left. Yeah, so having an isolated test for the class under test. let's have a look at the corresponding code, yeah, of this local test class. So you see it here. You're just seeing here the implementation. And in the setup of this test class, exactly those steps are performed. I already mentioned, yeah, creating a factory double object. We have it here, using the injector to put it to the static attribute. Okay, and then creating a doc double object, yeah, and using the factory double, yeah, to store it, yeah, and later on provide it. And if this is done for a singleton here, yeah, so if doc is a singleton class, there is just one doc object, yeah, then we can even do late configuration in the test methods, which means setup is executed before each test method. Maybe the test methods need different configurations of the doc double, once returning nothing, once returning a lot of good data, and once returning maybe an exception or so. Yeah. So here just one test method is shown, yeah, but the other test method could configure this double late, so in the test method after the injection, yeah, in completely different ways. So now we have a look at the definition of this local test class. And so we see here that the setup method we just looked at, the test method we have seen, yeah, and we are having this attribute in the local test class of the doc double, yeah. And of course, the setup method can create it, and test methods like the one here, we just have one right now, yeah, can then also access it, yeah, and configure it for the first time or further or whatever is necessary. Okay, so this is possible because doc is a singleton. How does this look like for non-singleton doubles? Yeah, and now it becomes a little bit difficult, but I hope I can guide you through this. So then the same test class for method under test, yeah, in case doc is not a singleton, so multiple objects of it are possible, yeah, then we can in the setup method, yeah, only create the factory double and inject it, yeah, so prepare for the isolation. But each test method, yeah, has then to create one or multiple doc doubles, yeah, do the configuration here, yeah, with by providing corresponding values to this creation method and so on, yeah, and then injecting all these doubles, yeah, in the sequence they should be used later on, yeah, into the factory double. Yeah, in other words, the class under test, yeah, during its the execution of the test, yeah, will first get the factory object, and then from this factory object once and here twice, yeah, ask for doc objects, yeah, and this will be first this doc double, and in the second call that doc double. Yeah, so the ones we injected one after the other will then be provided by the factory to the class under test. And this way we can even deal with the need of multiple doubles, yeah, with complete different behavior, because this first double could return no data and the second one could return good data, or that one returns an exception and then we don't even need the second one and things like that. Yeah, so I have full flexibility. Okay, so once again, we have a look at the definition, yeah, for the non-singleton case, because here we do have an attribute for the factory double, yeah, not for doc, yeah, and the reason is quite simple. If I just return, because we cannot complete the whole configuration and injection in the setup method, yeah, so we need to access this factory double also in a second method down here. Yeah, so this can only be done if this is an attribute. Yeah. On the other hand, yeah, we don't need the doc double before we can eventually configure it fully. Yeah. So we don't need an attribute for it. We can do all this locally. Yeah. Just create this local object and inject it, and that's it. Yeah. So no attribute is needed. So yeah, that's why we have here a slightly different situation. Okay. Now, this is already good what I have shown you. Yeah, it's just the point that there will be duplication. Yeah, why? I told you we want a test class for each method under test. Yeah, so to have a separation of concerns. Test cases for one method, yeah, are in this test class, and test cases for another method are in another test class. Yeah, so this kind of separation of concerns in the test world. Yeah, so we are having multiple test classes. If now each of these test classes, yeah, does the creation of this factory double and the injection, yeah, then we have duplication. And this is not necessary, yeah, because yeah, this class has this dependency, yeah, already in the product world, yeah. So of course, all the test classes, all the local test classes need the same test double factory, yeah. So we can simply extract this, yeah. And in this case, we have extracted it to a global base class, yeah, global test base class. And so you see here, we are going to have also a local base class, yeah, which is derived from the global one. Yeah, and then we have the specific method-specific test classes derived from this base class here. So this is what the symbols say. Yeah, and we will now see that all these new classes, global and local ones, yeah, have own responsibility, yeah, in order to avoid duplication and later on also simplify things. So let's look into that one first. Yeah, as I said, we don't want that the factory double is created and injected multiple times across our local test include. Yeah, so that's why we simply extract these two lines, yeah, into this base class here. And we are having this attribute, yeah, so that the derived test classes can still access the factory double in order to inject specific doc doubles, as we have seen. Such a global base class, yeah, is first of all needed for this here, yeah, these two lines here, yeah, but it could also be a place, yeah, where you put maybe test data, yeah, which you frequently need or so, that you also set it up here, yeah, and can then reuse it in all derived test classes. Yeah, so normally those base classes grow over time. Yeah, but the very simple version is what you can see here. What is left? Left is that the doc double hasn't been created yet, yeah, and hasn't been configured yet. Yeah, and this is now the responsibility of this local base class. So you see, we derive that one from the global one. Yeah, so we have this factory double creation injection mechanism already included. We don't have to repeat it. Actually, we don't even have to care about it any longer. Yeah. This is also an aspect of simplicity now. And we are again looking at the singleton case for the doc double. Yeah, so there exists only one. Yeah, so that's why we can have an attribute pointing to the one doc double. There won't be more. Yeah, and in its setup method, yeah, we have now the other two lines. Yeah, creation of the doc double. Yeah, and then injecting it into the factory double. Yeah, so that the factory can then provide it one after the other. In this case, just always the same. Yeah, so hope this was now clear. Yeah, that we have here a separate focus on the isolation. Yeah, so now we are fully isolated. This is the point. Yeah, so our class, yeah, whatever we do in such a specific test class derived from that one, yeah, that of course derived from that one, yeah, will never reach this productive class again. Yeah, because we have this double here, and that one looks at that class, yeah, and does never look at this class. Yeah, so that's why we have now already complete isolation. It is just that the configuration hasn't been done, but you see the arrow here. Yeah, so now the specific test class can focus, yeah, on the configuration of this singleton object here. Yeah, and I emphasize it, must only focus on it. Yeah, it doesn't have to care about anything else. Those classes here, yeah, already take away, yeah, a kind of the complicated part of this testable design. So let's have a look at this method under test. So you see here, we inherit from this local base class, yeah, and you know the global one is already a part of it. And yeah, so we start immediately with mo doc double, yeah, it exists, yeah, and start with the configuration. So we start with the test case immediately. Yeah, we are not dealing about injection and this kind of isolation stuff. No, the pure test case can now be written, and yeah, and since we have the name doc double, yeah, we don't even have to explain it. Yeah, it's immediately understood. Ah, I have a double for doc. Okay, now I'm configuring it. Ah, in this way or in that way. Okay, and now what happens then? Yeah, so pure focus on the test case possible. Okay. Yeah, so hopefully now you have understood why we need factories, why we need injector classes. Yeah. So in the end, what you see here is now the next level. Yeah. So we have already designed a clean class. Yeah. Now we want to design a clean package. And a clean package should be encapsulated. Yeah. So hide all its contained development objects except the one it exposes in its package interface. Can also have multiple package interfaces, but at least one. And so this of our package we focus on, yeah, which you call now the server package, yeah, because it serves one or multiple client packages. yeah, with its functionality. Yeah. Okay, so this is the package interface of the server package. And what is now in this package interface and what is not in it? Yeah, this is crucial. And so, of course, the functionality we offer, yeah, these client packages have to have a chance to access it somehow. Yeah, so the functionality is, for instance, one method here in this interface. This is the functionality, yeah, maybe with a deep data structure and then doing a lot inside the package, yeah, but that's the entry point, yeah. So how does one client package like that one, yeah, get to this functionality here? There has to be a factory, yeah, which is then returning this interface to the client package, as we have seen before. Yeah, it is just called external factory here, yeah, because we are then also having the need for an internal factory. Okay, so just to distinguish the two. And as we have seen, the factory has an interface. Yeah, the class of the factory, of course, has to be available. Yeah, because this is what this package says: get me the singleton object of the factory. Okay, so for this it needs the class and it receives the interface. And for testing, yeah, if I want to test, let's say, this package here in isolation, yeah, then of course I will work with the testable of this factory, as we have seen. Okay, and of course I need the injector, yeah, to get this double, yeah, into the static attribute here, so that it is used. And yeah, what the factory offers is in this case only this interface here. Yeah, so it says create object one, yeah, and what is returned, yeah, is then this interface here. You find the functionality the package offers, yeah, and once that is called, the whole execution is done inside. Okay, so this is all hidden, encapsulated. Yeah, all you see is this single method which offers the functionality. So, of course, the class of this interface is not in the package interface. Yeah, we have already seen that. Yeah, this product class in the very beginning, yeah, did not have any clue, yeah, or connection to the new class or so. Yeah, it's simply not there. Yeah, and likewise, yeah, also the client packages don't need the class of it. It just needs the interface. Yeah, and it is provided by the factory. So the class of it, you find it down here. And of course, for implementing this huge functionality here, many more classes are needed. I just have placed here two more. Yeah, there are probably many, many more. Yeah, and of them, yeah, not even the interfaces are in the package interface. Yeah, because they are not really needed by the outside world. They are just needed indirectly. Yeah, internally. So it then works like this. Yeah. So once this method is called, yeah, of course, we end up in this implementation here. And this implementation, let's say, has two dependencies, two classes which help it. And these are classes 2 and 3. Yeah. So how does class 1 get objects of class 2 and 3? Using the internal factory. Yeah, so the internal factory now offers objects of class 2 and class 3, what the external doesn't. Yeah, so this is this joint offering here. Yeah, so this means internally I have also full decoupling of class 1 from the classes 2 and 3 it depends on, using this internal factory. Yeah, so in the end, I'm using this mechanism, this clean design I'm talking about twice. Yeah, for the outside world, and then also for all the dependencies inside. Yeah, and of course, we also need this injector. So you see those 4 here, yeah, are the same. It's just external and internal. And here are the interfaces we need, and here are the classes we need. Okay. And it's, of course, a very good idea, yeah, to reduce the offering of a package, yeah, maybe to 1 or 2 methods, yeah, because then the contract, yeah, between the server package and the client packages is just the signature of these 1 or 2 methods. That's all. Everything else can be refactored anytime. Yeah, and this is why I call it then clean. Yeah, because it gives you the most control over your source code. Yeah, and the flexibility. So you can start introducing some parallelization and so on. No one will care. Yeah, because the contract is reduced to a minimum. Yeah, and that one you can easily keep stable. If inside you are now doing parallel processing, nice, yeah, because the performance increases, but outside world doesn't care. Okay. I just see it's not 3 o'clock. I should end, but now. So I will finish now quickly. I'm almost done. So this enables then, yeah, that we really implement the test pyramid. Yeah, component tests being the test of an entire encapsulated package. Unit test being the isolated test of a class. An application test, yeah, being the isolated test of multiple components. Yeah, working together, making up the application. This way, we can reach an isolated test pyramid. Okay, yeah, and this is just more information on the books. Yeah, you see, it starts with the modernization of legacy code. Yeah, more than 100 pages on a challenging example, a real-world challenging example, showing you the entire test-oriented improvement process I'm always proposing or propagating. Then part 2 is about the theory, yeah, how to develop the test infrastructure to do all the testing necessary here. And part 3 is then in case, yeah, you have a greenfield development, yeah, how can you do it completely different? Yeah, starting with skeletons, a lot of skeletons, yeah, which ensure the testability of your entire application and the implementation of the test pyramid. Yeah, and then completed by some software engineering tips and tricks and introduction to development and test tools. Clean design, what we have seen today. Yeah, so we have talked about the design of the classes, the test classes, the packages, and also bodies. Yeah, this is what I have not talking about. And the second part of the small ebook, yeah, it's just 100 pages or so, contains a training, yeah, where you can actually practice this with complete exercises and solutions at your own pace. Test data classes, as I already said, are object oriented representation of test data. So we cannot just represent data structures and tables, what we need here and there and everywhere, yeah, but also messages. Also object-oriented representation of messages, which make it really nice to read test code, which deals with the error handling. Yeah, and again, there is a training with complete exercises and solutions, so that you can practice all this. And here the parallel processing, yeah, is of course introducing to this class CL ABAP parallel, yeah, but it also shows an advancement of the test data classes, Yeah, so how these can be inherited from productive data classes, a really nice pattern. And what I emphasize over and over again, because you will not find it easily elsewhere, yeah, is how packages should be designed. I talked about it, but also how they can be refactored, yeah, if things change, yeah. And this is done in there. Okay, yep, so thank you very much.